Vehicle component manufacturing is shifting to lighter and more robust materials. The most promising materials are carbon fiber reinforced plastics, or CFRPs for short. They're 10 times stronger than iron. Thus, they raise the prospect of enhanced fuel efficiency for the transportation business. The hurdle preventing their widespread use is that they are non-recyclable. CFRP components are usually non-repairable and have to be disposed of after even being slightly damaged. They then have to be buried in landfills due to their low decomposability. This results in serious environmental contamination. However, NIMS has developed an easy way of introducing CFRPs to decompose at room temperature. Immerse a piece of CFRP into a liquid, the plastic quickly decomposes, leaving the carbon fibers behind. Moreover, the residual liquid can be recycled and used to make plastic products. This technology makes it possible to break CFRPs down into raw materials for recycling. This remarkable achievement was inspired by redox reactions in our livers. CFRP derives its extreme toughness from its combination of carbon fibers and plastic. Woven carbon fibers are resistant to breaking but very flexible. When this fabric is combined with a plastic, it results in a very tough, lightweight material. This combination displays higher bending strength than an aluminum plate. However, its poor recyclability has been a major hurdle. The plastics used in bags and bottles can be easily softened by heating. Some are even biodegradable. Thus, they can be recycled manually or naturally. However, this is not the case with CFRPs. CFRPs harden when heated and are extremely resistant to decomposition. Disposal requires incineration over a long period of time or landfill space. Some studies have recently been conducted with the goal of introducing CFRPs to decompose. According to these studies, incorporating SS bonds into CFRPs makes them decomposable using a strong chemical agent that breaks the SS bonds in the plastics. However, this method is fairly dangerous because the chemical is highly toxic. Dr. Masanobu Naito is a researcher pursuing advanced CFRP recycling technology. He is skilled in the bio-inspired development of new materials. He wanted to induce CFRPs to decompose more easily, making them reusable. He examined a lot of possibilities to find a solution, including heat treatments and chemical agents. In the end, his attention was drawn to a natural substance called glutathione, which he read about in a biological research paper. Let's watch the decomposition process of a special CFRP which includes SS bonding. Glutathione powder is dissolved in water. It is then diluted with an organic solvent, and a piece of CFRP is dipped in it. After 3 hours of mixing, all of the plastics have been dissolved, leaving the woven carbon fibers. How is this solvent able to induce CFRP to decompose at room temperature in only 3 hours? This is made possible by a unique property of glutathione. Glutathione can be found in our bodies, where it attaches to SS bonds, cleaves them, and moves on. SS bonds and molecules are broken down by glutathione. In this case, glutathione attaches to SS bonds in a CFRP, gradually cleaves them, and removes the resultant fragments. This reaction is eco-friendly and safe and takes place at room temperature. It is perfect for CFRP decomposition. Moreover, all of the decomposed plastics remain in the residual solvent. We can collect and recycle them after the solvent is evaporated.
少し見方を変えて、工業的な材料とバイオ材料のインターフェースというか、その辺を探してみたらなんか面白いことできないかなということで、この材料、こういう系を考えてみました。環境に優しいというところがポイントですね。
This method makes CFRP eco-friendly by allowing it to break down in a non-toxic solvent, producing recyclable products. This is expected to act as a tailwind to widespread use of CFRPs, contributing to enhanced energy conservation.